Good morning to my panel, Sir Aizan and Prof. Dr. Faiz Liu. I'm Eleana Lintau Koh, DE180023, and my supervisor is Dr. Rahmat bin Talib. My final year project title is Development of Filter Bank Multi-Carrier Modulation Performance Analysis Platform. I will start from the abstract of this project. Filter Bank Multi-Carrier, or FBMC, is a multi-carrier modulation technology that was developed from orthogonal frequency division multiplexing, or OFDM technique. FBMC makes better use of current channel capacity, which can provide higher data speeds within the same radio frequency bandwidth. The development of FBMC system for simulation stage become a difficult task since FBMC is still new, and a proper programming skill is required to simulate the process in FBMC technique. A graphical user interface, or GUI software platform, has been built to simulate the FBMC system with the effect of additive white Gaussian noise, or AWGN, using the MATLAB in analyzing and comprehend the FBMC technique. This project explains the process of MATLAB programming to simulate the FBMC technique with AWGN effect and development of GUI. The developed GUI is capable to provide signal spectrum plot, constellation diagram, and BER value at given SNR value. The output of this GUI is an important characteristic for FBMC in digital communication operation. Next is the background of the project. Digital communication is a process of transmitting data in digital form by using devices. It is easier as it can be done over large distances and can save a lot of effort. Digital communication is to reduce and overcome losses. The usage of digital signals improves the accuracy and clarity of communication. A message source data is transformed into a format that can be transmitted through the process of modulation. There are two types of modulation, which is analog and digital. In digital modulation, there are three different types, which is amplitude shifting keys, frequency shifting keys, and phase shifting keys. FBMC is a multi-carrier modulation technology that was developed straight from orthogonal frequency division multiplexing, or FDM, to address some of the problems. FBMC makes a better use of current channel capacity, which can provide a higher data speed within the same radio frequency bandwidth. Spectrum efficient and selective solutions are something that FBMC can make. A category of multi-carrier systems is FBMC system. Each user is assigned a different set of subcarriers because FBMC is designed to support several users at the same time on any specific RF channel. Next is the problem statement. In digital communication, bit error rate (BER) estimation is compulsory at receiver side to determine the performance of this system. This process needs to be done during simulation stage of the development of communication system in the study of latest modulation technique such as FBMC. For engineering students, to develop FBMC system for simulation stage become a difficult task since FBMC is still new, and a proper programming skill is required to simulate the process in FBMC technique. In order to help to learn and understand FBMC technique, a software platform based on graphical user interface, or GUI approach has been created using MATLAB in simulate the FBMC system with the influence of additive white Gaussian noise, AWGN. Next is the objective of this project. The aim of this project is to develop filter bank multi-carrier modulation performance analysis platform. The following are the objectives to accomplish the aim of this project. The first objective is to develop GUI for FBMC modulation using MATLAB. The second one is to integrate FBMC modulation algorithm with the developed GUI. And the third one is to verify the overall operation of GOI for FBMC modulation with AWG and effects. Next is the scope of this project. This project focuses on development of FBMC modulation performance analysis platform. A graphical user interface GOI software platform has been created to simulate the FBMC system with the effect of AWGN using MATLAB in order to analyze and understand FBMC technique. This software is used as it is easy as it provides point-and-click control of software applications. FBMC with the symbols 4 QAM, 16 QAM, 64 QAM, and 256 QAM are included in this project. By dividing the number of bits received in error by the total number of bits transmitted over the same time periods, the BER can be calculated. Let's proceed to the next slide. FBMC or filter bank multi-carrier. Multi-carrier modulation and OFDM are both modified in filter bank multi-carrier or FBMC. The shortcomings of OFDM are addressed by FBMC. With FBMC, available channel capacity is used considerably more effectively. Within a particular radio spectrum bandwidth, it offers better data rates and spectrum efficiency. In comparison to OFDM, the figure shows how FBMC gives enhanced bandwidth efficiency. Due to rectangular windowing, OFDM system shows side loops while FBMC system, the frequency range of a single subcarrier of energy was being focused. Next is the BER calculation. So that is the BER formula, which is BER equal to number of errors over total number of bits. So the ratio of bits received in error to all bits received is known as bit error rate or BER. A digital transmission system quality is determined using the BER. So the BER is determined by comparing the bit sequences sent and received and measuring the errors. The signal to noise ratio, distortion, and jitter are only a few of variables that affect the measure ratio. Next is QAM, also known as quadrature amplitude modulation. To form a signal, it is phase shifted by 90 degrees, modulated and concatenated with two carriers. Analog and digital QAM are the two forms of technology. For larger data rates, digital QAM is typically used. The transfer of either a 0 or a 1 is only possible at the two major signal points. Phase and amplitude values can be specified in a number of different places using QAM. These are all the constellation diagram of QAM. Next is GUI. GUI is another name for graphical user interface. The user interface that uses graphical components to let consumers interact with electronic gadgets. It is a crucial component of software application programming since it swaps out text-based commands with user-friendly action, enhancing human-computer interaction. The user can quickly locate, understand, and apply decision points. In other words, a graphical user interface or GUI enables you to operate your devices using a mouse, a pen, or even your finger. Next is the methodology of this project. This is the project flowchart, starting from the FBMC modulation with AWG and effects, and done the simulation to get the results. And then convert the FBMC modulation into GUI to get data of BER and SNR. From the data, it is easy to analyze and explain the performance of BER with AWG and effects. Next is the simulation of FBMC system in MATLAB. This is the block diagram of FBMC. This block diagram has transmitter part and receiver part. In the transmitter part, starting from the entering the data bits and then QAM symbols and proceed to SP, and frequency spreading and extended IFFT, overlap some and send to the channel. While in receiver part, starting from the channel where the data bits were sent, and then to SP and then extended IFFT and frequency spreading, PS and OQAM post-processing, demapping, and lastly recovered the data bits. Next is MATLAB programming. This is a table for system parameter in this programming. So the number of FFT is 1024, number of guards is 212, and number of factor is 4, and number of symbols is 30. In the programming, starting with the system parameter, it is important to define the system parameter so that the value can be used in the programming. After defining the system parameter, the prototype filter is applied for the zero frequency carrier and form the basis for all subsequent subcarrier filter. The overlapping factor K is the number of multi-carrier symbols that overlap in the time domain, which is used to describe the filter. Next is the development of GUI. This is the GUI structure. The push button in the input panel are used for the bit per subcarrier, and the edit text 1 in input panel is used to insert the value of SNR or signal noise ratio, and then the assist 1 is showing the signal spectrum of FBMC modulation, while assist 2 is showing the constellation diagram of 4 QAM, 16 QAM, and 64 QAM and 256 QAM. The edit text 2 in the output is for bit error rate. Next is the result for this project. This is the figure for 4 QAM. So on the left side of the figure is showing 8 dB of SNR, where the BER is 0.00043478. So on the right side of the figure is showing that the BER is 0 when the number of SNR is increases. The constellation diagram shows the AWGN effects for 4 QAM. As you can see on the left side, the the scatter diagram is not clear. It's very hard to see that the constellation diagram is 4 QAM, but when the SNR is increased and the BER is 0, you can see clearly that that is a constellation diagram for 4 QAM. So the next slide is showing the result for 16 QAM. So on the left side of the figure shows 50 dB of SNR. As you can see, it is not clear. We still cannot see the constellation diagram of 16 QAM clearly, but once the SNR is increased, the BER is 0, we can see clearly that this is the constellation diagram for 16 QAM. And then the next is the result for 64 QAM. As you can see on the left figure shows the constellation diagram is not clear, as we use which I use 21 dB of SNR, and it still cannot show the very clear constellation diagram of 64 QAM. But once I increase the number of SNR And once the BR is 0, you can see the constellation of 64 QAM over here on the right side of the figure. Next is for the result for 256 QAM. So on the left side, I put on 26 dB of SNR. You can see here the constellation diagram is not clear, but once I increase the SNR, same as the previous result, I increase the SNR number of SNR, and the BER is 0. We can see a very clear of constellation diagram of 256 QAM. So in the result shows the development of FBMC modulation using GeoEye MATLAB based on the GeoEye structure design in this project. And the result also show the integration of FBMC modulation algorithm with the developed GeoEye. The signal spectrum of all QAM has the same shape and required the same channel bandwidth. And the constellation diagram of 4 QAM, 16 QAM, and 64 QAM, and 256 QAM in the result verified that overall operation of GUI for FBMC modulation with AWGN effect. In this analysis, BER of 10 power of -3 or better is obtained with appropriate SNR value and confirm that the developed GeoEye can provide performance evaluate of FBMC technique. In the conclusion is based on the title, problem statements, and the objective of this project. This project has achieved the goals and solved the problems stated. The development FBMC modulation using GeoEye MATLAB based on the GeoEye structure design is shown in the result. The development of FBMC system for simulation become easier with a software platform based on graphical user interface GUI approach has been created using MATLAB to simulate the FBMC system with the influence of AWGN. The integration of FBMC modulation algorithm with the developed GUI is also shown. The constellation diagram of 4 QAM, 16 QAM, 64 QAM, and 256 QAM is in the result verified the overall operation of GUI for FBMC modulation with AWGN effects. For the recommendation, in future, this project can be improved in designing the GeoEye structure to make it look informational. It is easier to make an analysis through a complete and informational result. This project can also include BR versus SNR in GeoEye. Last but not least, this project shall develop other modulation using GeoEye MATLAB to analyze the performance. That's all from me. Thank you.